This is video 23. In this new part, we aim to prove the jail lemma. To achieve this goal, we modify a previous result called the window movie lemma. In this video, we introduce some definitions. First, we recapitulate some definitions. Consider a vector v. Here the vector v is 5, 3. Let p be the sum of the coordinates of vector v. Consider the height function associated to vector v. Along this part, we will consider cuts of the grid made by discrete lines of direction v. Consider an integer h. The window of the cut of the grid made by a discrete line of direction v and height hp is called wh. The period of this window is p. The cut of the grid associated to this window is g2h and g2h plus 1. Here we have drawn w0 in gray. This window is made of all the positions of height between 0 and p-1. The graph g0 is the left side of w0 and contains all the positions of height greater than 0. The graph g1 contains all the positions of height strictly less than 0. Here is the window w1 and its cut of the grid g2 and g3. w1 contains the positions of height between p and 2p-1. Then the window w1 and the window w0 do not intersect. Also note that the graph g2 contains the positions of height greater than p. Here is w-1 and its cut of the grid g-2 and g-1. w-1 contains the positions of height between -p and -1. Then the window w0 and the window w-1 do not intersect. Also note that g-1 contains the positions of height strictly less than 0. Thus if we consider all the windows wh, we obtain a partition of the positions of the grid. For any position of the grid there exists a unique integer h such that this position belongs to the window wh. Note that this remark is not true for the edges of the grid. Here for any of the blue edge, there exists a window wh such that it belongs to wh, but for the edges in red, they are between two consecutive windows. These edges have one extremity in a window wh and the other one in the window wh plus 1. Note that we consider directed edges here. The window movie lemma will focus on the edge in red. Now consider a vector w such that the window w0 translated by the vector w is the window w1. Then the translation of the graph g0 by w is the graph g2 and the translation of the graph g1 by w is the graph g3. Finally, to resume, here is w0 in gray. Here is g0 in hatched. Here is g2 in hatched. Note that this graph is g0 without the positions of the window w0. It contains all the positions of height more than 8. Here is g1. And here is g-1. Note that this graph is g1 without the position of the window w0. It contains all the positions of height less than -1. Now we define the output clues in movies. These notions will be used only in the following video. Consider a path assembly P. An output glue is an edge of the grid labeled by a glue label. The output glue GI of the path assembly P is the edge between PI and PI plus 1 labeled by the glue on the abuttal side of these two tiles. Now, consider a window obtained by a discrete line. Here we consider W0. Now consider all the output glues of the path assembly P with one extremity in W0 and the other extremity in W1. Here we have 4 output glues of P. The movie of P of height 0 is obtained by sorting these output glues according to their order in the path assembly P. Here the first output glue of the movie is G7, the second output glue of the movie is G26, the third output glue of the movie is G33 and the last output glue of the movie is G41. Now, the graph G2 is hatched. We have drawn in gray the restriction of the path assembly P to the graph G2. Since the tiles in gray are not connected, then they are not a path assembly. Here, the graph G1 is hatched. We have drawn in gray the restriction of P to the graph G1. Now we can state the window movie lemma in the following video.